A car horn blares behind you. Your shoulders jump. Your heart slams once hard before your mind even catches up. You didn't decide to flinch, you didn't have time to. By the time you consciously register the sound, your body has already reacted. That gap, that sliver of a second between the world happening and you noticing it, is one of the strangest and most ancient features of being human. Your brain was built to protect you before you were ever aware there was something to be protected from. Most people assume seeing comes first. You see the danger, you understand it, then you respond, but that's backward. Your brain has a shortcut wired directly into it, a fast route that bypasses conscious thought entirely. Neuroscientist Joseph LeDoux spent decades studying this pathway at New York University. He found that a rough, blurry signal about potential threats reaches a small almond-shaped structure deep in your brain called the amygdala almost instantly, arriving there faster than a clear, detailed image ever could through your visual cortex. LeDoux called this the low road. It's crude, it's imprecise. But it's fast, and speed is what mattered when the cost of hesitation was your life. Think about what that means. Somewhere in your skull, there is a system that would rather you flinch at a coiled garden hose than risk missing an actual snake. It doesn't wait for certainty, it acts on probability. Better to jump 100 times at nothing than to freeze once at something real. This shortcut didn't appear by accident. For most of human history, the margin between life and death was measured in fractions of a second. A rustle in tall grass, a shadow crossing overhead, a shape moving where nothing should be moving. The humans who paused to carefully analyze every rustle before reacting didn't often get the chance to pass on that careful, deliberate temperament. The ones who jumped first and asked questions later did. Over hundreds of thousands of years, that bias toward instant reaction got etched deeper and deeper into the architecture of the brain. Psychologist Arne Öhman at the Karolinska Institute tested this directly. He ran experiments showing people photographs of snakes and spiders mixed in with neutral images like flowers and mushrooms. People picked out the snakes and spiders faster, and their skin conductance, a measure of stress response, spiked before they could even say what they'd seen. Öhman's participants weren't from cultures where snake bites were common. Many had never encountered a real snake in their life. It didn't matter. The fear wasn't learned from personal experience. It was inherited, passed down through a nervous system shaped by ancestors who lived and died by how fast they noticed the wrong shape in the grass. Here's where it gets stranger. Your body doesn't just flinch at obvious danger. It flinches at anything that resembles danger even faintly. A dark shape, a sudden movement at the edge of your vision, a loud, sharp sound with no clear source. Your amygdala doesn't need the full picture. It works off pattern matching, off rough outlines and general shapes, sorting the world into two categories in milliseconds, safe or maybe not safe. And when it lands on maybe not safe, it doesn't ask for permission. It fires a cascade, adrenaline flooding your bloodstream, your heart rate spiking, your muscles tensing, all before the rational, slower parts of your brain even finish processing what happened. Neuroscientist Michael Davis, working at Emory University, studied this cascade using something called the acoustic startle reflex, the jump you make at a sudden loud noise. He found the pathway involved is almost comically short. A sound hits your ear, travels through a handful of neurons, and triggers a full-body flinch in under a tenth of a second. Compare that to the roughly half a second it takes for you to consciously recognize what the sound even was. Your body has already moved before your mind has caught up. You are, in a very real sense, living slightly behind your own reflexes. Why does this matter now? You're not dodging leopards in tall grass anymore. Most of what triggers this ancient alarm system today isn't a predator at all. It's a slammed door, a phone buzzing unexpectedly in a quiet room, a stranger stepping too close on a crowded street. Your amygdala doesn't know the difference between a genuine threat and a modern inconvenience. It reacts to both with the same primal urgency, because as far as your oldest neural circuitry is concerned, nothing has changed. The world outside your skull looks completely different than it did 100,000 years ago. The alarm system inside it does not. This is also why fear can feel so disproportionate sometimes. Why a harmless email from your boss can trigger the same tightening in your chest that a real emergency would. Why public speaking, something that carries no physical danger at all, can send your palms sweating and your pulse racing as if you were standing in front of an actual predator. Your body is running software designed for a world of claws and open plains, trying its best to make sense of a world of deadlines and notifications. It isn't malfunctioning. It's doing exactly what it evolved to do. It's just aimed at the wrong targets now. There's a strange comfort in understanding this, though. That flinch you feel, the one that seems to come from nowhere, isn't weakness. It isn't overreaction. It's a direct transmission from every ancestor who ever survived a close call, encoded into your body and passed down until it became you. Every time you jump at a loud noise or feel your stomach drop before you know why, you're experiencing a system that has been refined and tested across more human lifetimes than anyone can count. It has never once needed your permission, and it never will. It doesn't work for the version of you that reads and reasons and plans ahead. It works for the version of you that simply needs to still be alive in the next 5 seconds. So the next time a car horn makes you jump, or a shadow at the edge of your vision makes your stomach lurch before you've even turned your head, remember what's actually happening. You are not overreacting. You are not broken. You are running the oldest, most trusted piece of software your species has ever built, one that has kept every single one of your ancestors alive long enough to have you. The world you live in has changed almost beyond recognition. The thing keeping you jumping at shadows hasn't changed at all, and in a strange way, that's exactly the point. Long after the car horn fades, long after you've caught your breath, that same ancient alarm is still standing guard, quietly waiting for the next shape in the grass.